Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's video newsletter, well, we're going to answer a comment that someone's left on one of my videos. I think it was on the define video when I was talking about define, measure, analyze, improve and control. It's from a gentleman by the name of Bruno. And Bruno's asking, he's finished the define phase of his project, he says, but he wants to know, when am I going to start analyzing the causes of my problem? And because this is a little bit difficult to respond to in a message or a mail, easiest thing is to make a video and explain the two techniques, because there are basically two techniques of analysis that you're going to have when you're looking for your causes on your process problem, on your Six Sigma project. So here's the question. When to analyze the problem causes. Okay. Now the obvious answer to this, of course, is if you go define, measure, analyze, it would be in the third phase, in the analyze phase. But that would be too general an answer, because people get mixed up about how detailed, how mathematical, how statistical we want them to get with this analysis. And this is really important. When you're doing the define, and I would typically do the define and the measure phase together, because to me, I can't define the problem without doing some measurements, getting some information in front of me. So the define and the measure really come together. There's some basic questions you need to be asking yourself. And one of the basic questions is, as far as my problem goes, what is my problem? Is it, if we talk statistically, is it a problem with the signal? Or is it a problem with the noise? I would also say, is it a problem with chaos? Or is it a problem with control? Because the two analysis techniques then are going to be very, very different. So, what's the difference between signal and noise, chaos and control? Let me show you. So when you're doing the measurement phase, you're going to start collecting data on your measurement of choice, your measure of success. So what I want you to do is plot a graph. First of all, run chart. Okay, so you're going to go run chart. Then what you should do is a histogram. And then if it's appropriate, because you have two-sided tolerances, I would finish off with a CPK analysis. Now, why am I going run chart, histogram, CPK? Because they'll help to answer these two questions. I've got a problem with signal. Have I got a problem with the noise? So what's the difference? Well, this one, for instance, look, this process is perfectly centered. The average is perfectly hitting the target. What we have a problem with is the fact that it is spread too much. That is a problem of noise. That's a problem of noise. Now this has a particular way to answer it, so that's a problem with noise. But how about if what we've got is a different looking performance? So maybe it looks like this. Maybe that's the target. Of course, I'm going to draw a histogram, just to make sure the data looks sensible. But then when I do the CPK diagram, of course, what I'm going to get is something that's looking very high. So I get something that looks like this. So I've got lots of defects over this side. Now that is a problem with signal. We're not centered. The signal is about moving the average, moving the mean. The chaos is about changing the standard deviation. And those two techniques are very different. If you're trying to move the signal, this technique, to understand this potentially, is going to be quite mathematical. So you're going to be looking possibly at regression information. You might consider doing a design of experiments in order to understand how to move that average, around. This problem, however, this is a different problem altogether. Now this is a problem of noise, it's a problem of control. What we need to do here is we need to use a cause and effect diagram. Cause and effect diagram, and you need to identify every variable in the process that creates this problem, that creates the noise here. So these would be things like settings, speed, temperature, etc. They would be things like maintenance routines. How often do we clean the filters? How well do we clean the filters? Do we clean them properly every time? Maybe do we run to breakdown? So do we run the filters until they're completely finished and can't be used again, and maybe we put up with the filters being in poor condition for 2-3 weeks before we change them? Or do we have a maintenance where we change the filter every 4 weeks, regardless of whether it's blind and finished or not? So we're going to identify all the variables, settings, maintenance routines, maybe adjustments that people choose to have. Now I've got a little example here, look. Now in order to fill out the cause and effect diagram, what I also do is a flow diagram. So the idea of the flow diagram is that you visit every box. So you can see the flow diagram on a process here. So we do the flow diagram because processes are quite complicated. You can see this is quite an involved flow diagram. What I'm going to do is visit every box on the diagram. And as I go to the box, I'm going to ask the question, what are the variables? What are the things I should be controlling that would get rid of this problem, that would bring the noise in? And I'm going to go through this in fine detail. When I say settings, I'm not going to write them as settings. You can see here on this cause and effect diagram, these are individual settings, time settings. So how much time to if you were soaking something in an oven, how much time for soak zone 1, how much time for soak zone 2, how much time for soak zone 3, what's the temperature of zone 1, what's the temperature of zone 2, what's the temperature of zone 3. So you can see all these variables on this cause and effect diagram. They are in absolute detail because you've got to agree a defined rule for every single one of them. So this is detailed work. Fixing chaos. This is going to take you 3 months to do this. Because going through all these, coming up with rules, maybe putting things back in as good as new condition. So when you agree new maintenance rules, you might have to wait a few weeks before you can get all those maintenance things back in control. This typically takes you months to put this right, but you are going to analyze, because you're going to go define, measure, and then you're going to analyze your causes. But one technique could be cause and effect if you're trying to get rid of the chaos. One technique could be very mathematical if you're trying to understand how to put your process on a specific target. So you have to wait until you've got measurement. You have to wait until you can draw pictures of what your process is doing. Then ask yourself the question, am I trying to move the mean or am I trying to move the standard deviation? And when you have that answer, Bruno, then you will know what analysis technique to use. Now if you want to know more about this, you can buy my book. This is all about Six Sigma. Define, measure, analyze, improve and control. It tells you all about cause and effect analysis, run charts, histogram, CPK, design of experiments. It's all in. Drink tea and read the paper. You can get this on Amazon. I believe you can get it on lulu.com as well. So if you want to know more, please buy my book. There is also an electronic copy on lulu.com. Also, please subscribe, click like on the video. That would be fantastic to help the channel, etc., get to more people. So thank you very much for that. And if, like Bruno, you would like to ask a question, you would like to engage me in some conversation, something you don't agree with or something you think I've got wrong, and you would like me to put that right in a video, please send me some questions. I will make videos for the best questions, the ones that are most interested to all my viewers. You pose me questions, I will either answer the comment or, as I've done for Bruno here, I will make you a specific video. So I hope to hear from you soon.